Welcome to lecture series of digital electronics. Today we are going to talk about Boolean algebra. I am Dr. G.Mamatha, working as associate professor in J&T College of Engineering, Anantapur. What is Boolean algebra? Boolean algebra is a system of mathematical logic. It is an algebraic system consisting of set of elements 0 and 1, two binary operators called OR and one unary operator NOT. It is a basic mathematical tool in the analysis and synthesis of switching circuits. It is a way to express logic functions algebraically. And in Boolean algebra, there are some postulates and laws. So postulates of a Boolean algebra are set of logical expressions that we accept without proof and upon which we can build a set of useful theorems. So those postulates are nothing but the and, or, and not. So AND operation, we already seen that 0.0 is a 0, 0.1 is a 0, 1.0 is a 0, 1.1 is the 1. So here we can say that we can accept without any proof of this postulates, and the same way R. So R also 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. And the NOT operation is nothing but 0 bar is a 1, 1 bar is a 0. This we call as the postulates. So for that postulates there will be no proof, we need to accept it. And also there are certain laws in Boolean algebra. Those laws are similar to that of mathematics, complementation law. So that the complementation law is nothing but 0 bar is a 1 and 1 bar is a 0. So if you take A is equal to 0, then A bar is equal to 1. Suppose if you take A is equal to 1, then A bar is 0. So if A bar is equal to A, you take double bar, then it will become A. So this we call as a complementation law and law. So this AND law is similar to that of AND operation. A dot 0 is nothing but 0. This is called as a null law. And also A dot 1 is nothing but A. So this is called as identity law. And A dot A equal to A. And A dot A bar is equal to 0. So these all things we need to remember while deriving or simplifying Boolean expression. So here also we can verify this. Suppose if A dot 0 is equal to 0, suppose if A is equal to 0, 0 dot 0 is 0. Suppose if A is equal to 1, 1 dot 0 is equal to 0. So A is in anything you may take it as a 0 or 1, but this A dot 1 is always become A. A dot A is always become A. A dot complement of A is always 0. A dot 0 is 0. So this is a AND law. And in the same way, OR law says that A plus 0 is equal to A. So this is called as a null law. And also A plus 1 is equal to 1, that is identity law. And then A plus A equal to A plus A bar equal to 1. So here also we can take A is equal to, if you want to verify this one, suppose if A is equal to 1, so here 1 plus A bar is 0, 1 plus 0 is equal to 1. So this is correct. So in that AND law and OR law, we can take represent with a literal A, and then we can say that A is maybe any value, it may be either 0 or 1, but a plus 0 is always a. A is either 0 or 1. A plus 1 is always 1. A is either 0 or 1. A plus a is always a. A plus a bar is always 1. So this is the OR law. And then one more law is the commutative law. So this commutative law says that a plus b equal to b plus a. Or else if you take three literals, a plus b plus c equal to b plus c plus a. That is equal to c plus a plus b equal to b plus a plus c. So that is commutative law. And in that is commutative law with the plus operation. And if you take commutative law with a dot operation, so there a dot b equal to b dot a, or a dot bc equal to b dot c a, or equal to c dot a b, or equal to b dot a c. That is commutative law. And one more law is the associative law. So that associative law, using plus operation, we can write it as a plus b plus c equal to a plus b plus c. And if you take four literals, a plus b plus c plus d equal to a plus b plus c plus d. Otherwise, we can write it as a plus b plus c plus d. So this is the associative law using plus operation. And we can also represent this associative law with the dot operation. So that is a dot b c equal to a dot b dot c. Otherwise, a dot b c d. If we take four literals, so a b c d, a b c d also can be written as AB dot CD. So in that, certain laws we need to use for Boolean algebra simplification. And that summary of all the laws, and then postulates or the theorems, and the dual of that one. So given here. So identity element x plus 0 is x, but the dual is x dot 1 is x. Complementation, x plus x bar is equal to 1, whereas dual x dot, this plus will be replaced with dot in the dual. So x plus x bar is equal to 1, x dot x bar is equal to 0. If it is 1, it will become 0. So x plus x is equal to x, x dot x is equal to x. X plus 1 is equal to 1, x dot 0 is equal to 0. That is null law, identity law. And then involution is x bar whole bar is equal to x. So that is nothing but x bar whole bar is 2 bar will get cancelled, will get that x. And there will be no dual for that one. Right, and then commutative law is x plus y is equal to y plus x. So there the dual is this plus will be replaced with the dot. So here xy equal to yx. Associative law, x plus y plus z is equal to x plus y plus z. Whereas dual plus sign will be replaced with dot. So x dot yz equal to xy dot z. And then distributive law, x plus yz is equal to x plus y, and then x plus z. So that is a distributive law. Whereas the dual of that one is nothing but this plus sign will be replaced with dot. So that is x dot y plus z is equal to xy and then xz. So De Morgan's theorem is nothing but x plus y whole bar is equal to x plus y whole bar is nothing but so x bar y bar. So this plus operation will be replaced with the dot, and then complement will be distributed. So and the dual of this one is nothing but here the plus operation will be replaced with the dot. So x y whole bar. So that is nothing but so x bar plus y bar. So here this complement, this dot operation will become plus, and this is bar and this is bar. And then absorption law. Absorption law is nothing but x plus xy is equal to x. So x plus xy is nothing but we can take x as a common. So 1 plus y. So that 1 plus y can be write it as 1 here. 1 plus y can be write it as with the identity here by null law. This can be write it as 1. So x dot 1. So this is nothing but the x. So that is absorption law. Distribution law. There are again two laws. One law is a b plus c can be write it as a can be multiplied with b and a can be multiplied with c, ab plus ac. And second law, a plus bc can be write it as a plus b and then a plus c. And one more law is redundant literal rule. Redundant literal rule. That is a plus a bar b equal to, here also you can write it as a plus b. So a plus a bar, a plus b. A plus a bar can be write it as a, then a plus b. And the second law is a into a bar plus b can be write it as ab, because a into a bar equal to 0, a b can be write as it is. And then idempotence law. So that is this law is nothing but a dot a equal to a. Second law says that a plus a equal to a. And then absorption law. This absorption law says that a plus a dot b equal to a. So that is, if you take common a, then 1 plus b. So 1 plus b will become 1. So a dot 1 that is equal to a. That is absorption law. And then consensus theorem. This theorem is theorem 1 says that here AB plus A bar C plus BC equal to AB plus A bar C. We need to prove that LHS equal to RHS. So here you have to see that A, B, A bar, C and then B, C. One literal A is missed here. So this is similar to that of that is AB plus BC plus CA. So here A and A bar terms are there. So we can keep as it is, and whatever remaining term is there, that can be neglected. So that gives that the final theorem result. That also can be proved like this. So here you have to take AB plus A bar C plus BC dot 1. So this one can be write it as, this one can be write it as AB plus A bar C plus BC. Here one literal is A is missed here. So that A can be write it as A plus A bar. So which is equal to 1. So if you multiply those bracket terms, so this can be write it as AB plus A bar C plus ABC plus A bar BC. So here we can take common terms. AB is common here, AB is common here. So A bar C common here, A bar C common here. So when you take AB is the common, so here this is 1 plus C. And then A bar C can be taken as common, so therefore 1 plus B. So here 1 plus C is 1, so AB dot 1, A bar C dot 1. So can be finally written as AB plus A bar C. So which is equal to RHS. So which is LHS equal to this RHS. So this is the consensus theorem. And consensus theorem 2 is, this is 1, and 2 is duality of this one. So this AB can be written as A plus B plus plus will become dot. So A bar plus C dot B plus C equal to, here A plus B dot A bar plus C. So we need to prove that LHS equal to RHS. So for this one you have to take LHS side. So this is A plus B, A bar plus C, B plus C. Can be write it as, if we take these two terms, so here A dot A bar plus A C plus A bar B plus B C. This has to be again dot operation with the B plus C. A dot A bar will become 0. So here AC plus A bar B plus BC has to be again dot operation with B plus C. So this can be write it as ACB plus A bar B B plus B C B plus ACC plus A bar B C plus B C C. And if you see that this ACB can be write it as ACB plus B dot B can be write it as B. So A bar B. B dot B can be write it as B. So this is BC. And C dot C can be write it as C. So A C. And then A bar B C. This C dot C can be write it as C. So this is B C. Here one BC, here one BC. So x plus x can be write it as x. So 1 BC. So here this can be write it as ACB plus A bar B plus BC plus AC plus A bar BC. Now if you observe that here A bar B is common, A bar B is common, and again here AC is common, here AC is common. So if you take that AC like 1 plus B plus A bar B, if you take 1 plus C plus B C. So here 1 plus B can be written as 1. So A C plus A bar B plus B C. And there is no further simplification here. Now we need to take the right hand side. So this right hand side is A plus B A bar plus C. If you multiply these two, A dot A bar plus A dot C plus A bar B plus B C. So A dot A bar will become 0. So this is nothing but AC plus A bar B plus B C. So AC A bar B B C B C. So LHS equal to RHS. So these two are the consensus theorem. And again De Morgan's theorem. So De Morgan's theorem is nothing but, so law 1 says that A plus B whole bar is equal to A bar dot B bar. Similarly, if you take A plus B plus C plus D plus, the same way whole bar can be write it as A bar dot B bar dot C bar dot D bar, and then law 2 says that A dot B whole bar is nothing but A bar plus B bar. Similarly, here you can take any literal A dot B dot C dot D dot whole bar is equal to A bar plus B bar plus C bar plus D bar, like that. So this is the De Morgan's theorem. And we can take some examples and we can do that, simplify that using De Morgan's theorem. So example, if you take that, suppose if f is equal to ab whole bar cd plus e bar f again ab whole bar plus cd whole bar. Suppose this is the example we have. Now we need to simplify using De Morgan's theorem. So here we can write it as dot operation has to become plus and the plus operations will become dot. So here this will be ab bar and then whole bar. So this dot will become plus here, and again this will be separated. So cd plus e bar f whole bar. This will become plus. So here a b whole bar plus cd bar whole bar. Right now here again this two bars will get cancelled. So this will be a b. So plus, and again here if you if this De Morgan's theorem, this plus operation will become dot. So cd bar dot e bar f whole bar. So this plus will be as it is. Now this whole bar, by using De Morgan's theorem, ab whole bar dot cd bar bar. So these two bars will get cancelled. So here how can you write this one? So this is ab plus this cd whole bar can be write it as c bar plus d bar, and e bar f whole bar can be write it as e plus f bar and then plus a b c d is the simplified version of a given example, by applying De Morgan's theorem. So, and if we take one more example like f is equal to ab bar plus a bar plus ab, and we need to simplify this. So this can be simplified using De Morgan's theorem. So using De Morgan's theorem, this plus will become dot and this plus will become dot, and this whole bar will be divided. So this can be write it as ab bar whole bar and then a bar whole bar dot ab bar. So these two bars will get cancelled. So you can write it as like a b, like and again a b dot a. This can be write it as a bar plus b bar. So ab dot a dot a can be write it as a. So here this can be write it as a b a bar plus b bar. So this can be again write it as a bar b plus a b b bar plus a bar a b a bar a b b bar. So here a dot a bar can be write it as a bar a b can be 0 dot b b dot b can be write it as 0. So here 0. So the final is the 0. Reduced version of this one is 0, right? And then like this we can take any example and we can simplify, or we can apply De Morgan's theorem for solving that expression, Boolean expression.